find the natural frequency of a vibration of a spring mass system arranged in an inclined plane. Okay. Now, guys, if you look into this particular problem, yes, they have mentioned using Newton's second law of motion. Am I correct? So now, as I said that whenever it is not mentioned, you can use any method which you find suitable. But here they have already mentioned you the Newton's second law of motion, and that is why obviously you cannot use any other method. Is it clear? Okay. So now what you can see that this is an inclined plane, right? This is an inclined plane. Okay, and on inclined plane there is a mass which is connected to the spring on both the sides, and the spring is fixed at the either end, right? You can see that if the K2 is fixed at this end, K1 is fixed at this end, and the mass is connected between the two springs. Okay. Now first of all we will find out the K equivalent. Now what is K equivalent? K equivalent is nothing but, now first of all, can you identify whether the springs are in a series or springs are in a parallel? Yes, anybody? In this case, K1 and K2 are parallel or
Series.
series? Yes? Anybody?
Series.
Series. Anyone else?
Series.
Anyone else? Now, as I said earlier that when the two springs are connected in such a way that there is no any mass or no any damper in between them, then they become a series. Okay. Now here you can see that it is not necessary that the spring should be connected in such a manner, K1 and K2. So this is called the parallel condition. If the two springs are connected in such a way, let us say K1 and K2. Okay. Now there is no any mass, no any another element between these two, then you can say that the springs are in the series. But you can see that the K1 and K2 are connected to the mass in between them. Okay. So in such case, this can be called as a parallel condition. Okay. So remember always, I have already explained you. So K equivalent is equal to K1 plus K2. So this will be the first step what you have to understand, right? So either you can use K1 plus K2 or you can use K equivalent. Okay. Now first of all, let us understand the equilibrium condition. What do you mean by the equilibrium condition? Okay. Now I will draw one figure, a VD diagram. Let delta is the static deflection. First of all, we have to draw the diagram for the equilibrium method. Okay, why equilibrium method? Because this mass is connected at the inclined plane. Na? Let us say this is the inclined plane, and this mass is connected at the inclined plane. Okay. Now you know that the gravitational force of the mass will be acting in a downward direction, right? Mg. Now because of this gravitational force, and again this mass is placed on the inclined line, this mass will move downwards due to the gravitational force. See, the system is not a dynamic system. I haven't applied any x. I haven't applied any, you can say, initial displacement to the system. So system is not vibrating. System is not in an equilibrium condition. The system is in a static equilibrium condition. But before the mass settle down, because of this gravitational force mg, the mass m will move downwards, right? Am I correct? So when the mass m will move downward, you can see that there is a deflection in the spring K1 and then there will be the deflection in the spring K2. Now since mass will move in a downward direction, obviously due to the momentum, due to the gravitational force, the mass will move down the inclined plane. Means what? This K1 will get elongate, this K1 will get elongate and this K2 will get compressed, right? This is a natural process in an equilibrium condition. And we are assuming that the corresponding deflection in the spring K1 and K2 will be same, that is equal to del. So del is nothing but a static deflection in the spring. And now once the del occurs, once the static deflection occurs inside the spring, both the spring, the mass will settle down. Okay, and then you will apply the x. What is x? You will apply the initial displacement. I hope it is clear to all of you. Is it okay? So this I have explained you in the case of the D'Alembert's principle. See, basically I have told you that the k into delta will get cancelled with the mg. Okay, but we have to show it here. Obviously k into delta will get cancelled with the mg, but you have to show it here. You have to solve it here. Okay, so let's start with, now have you understand the FBD? How is the FBD? This is the FBD, right? Let us say this is a mass m. Okay, and we know that this mass mg will act in a downward direction. Okay, now let us say this is a theta. Okay, if this is a theta, so this will be cos component, mg cos component, and this will be mg sine component. Okay, now mg cos component, mg sine component I have got. Now we know that the movement is like this. Okay, you can say the movement means what? The mass is moving downwards in this direction of the arrow. Okay, so what will happen? the spring will get compressed in the opposite direction. That is K equivalent into delta. What is K equivalent? K1 plus K2 into delta. So what is the deflection? Basically K into delta, na? But it is, instead of K into delta, you have to write K equivalent into delta, because there are two springs, which will be opposite to the moment of the mass, right? And mg sin theta as usual, and mg cos theta as usual. Is it clear? Now please message me, have you understand this free body diagram in case of the equilibrium method? So I can start solving the, hello? Is it clear how I have drawn this FBD in case of the equilibrium method? Message me yes or no. Okay. Now from this equation, I have two forces. One is K equivalent into del, and one is mg sin theta into del, horizontal forces, right? So what I'm getting from this, I'm getting K equivalent into del is equal to mg into sin theta, right? Okay, and what is K equivalent? K1 plus K2, because they are in the series, into del is equal to mg into sin theta. So let me call this as equation number 1. So this is equation number 1, that is K1 plus K2 into del is equal to mg into sin theta. Okay, because both are acting in the opposite direction, right? So both are equal and opposite. Okay, now next. Now, now what we'll do? Now let us assume that you are giving a small displacement x to the mass m. Now guys, you already know that whenever you are giving a small displacement x, let us say in the downward direction, initially there was a static deflection due to the mg, mass of the, or you can say the weight of the mass, that is mg, right? So now because of the x, what will happen? X dot will be induced, x double dot will be induced. Direction will be equal to the x. Okay. Now because of this x dot, the system will start vibrating, the system will start oscillating, and now we have to find out the natural frequency Fn. Okay. So this is the step number 2. So we'll go to the step number 2. So what is step number 2? But the diagram will remain same. Only instead of you are just giving a small displacement x, let x be the small linear displacement given to the mass m in the downward direction. So what will happen? This K equivalent delta will get added with the x. So this total spring force will be K equivalent into x plus delta, because K equivalent into delta is the static equilibrium, is equal to the spring force at a static condition. So x will get added into it. Okay. Rest mg sin theta, mg cos theta, mg will remain same, and again x dot and x double dot in the direction of the x, that is applied force, will get induced. Okay. So these two forces we have drawn. Now what they are saying? They are saying apply the Newton's second law of motion. What is Newton's second law of motion? Summation of F is equal to ma, right? This is Newton's. If they say apply the D'Alembert's principle, summation of inertia forces plus external forces is equal to 0. That is the statement. Or if they say kinetic energy, energy method, total energy equal to the constant. So whichever method you apply, you will get the same answer, natural frequency. Okay. Now summation F is equal to ma. As I earlier said that in case of the Newton's method, you have to always take care of the sign convention. It is very, very important. Okay. Now summation of F. F means what? The external forces you are acting. Now what are the external forces here? Mg sin theta. Mg sin theta is towards the right. So as per the sign convention, we will take it positive. So mg sin theta, right? Mg sin theta. Then this is what? K equivalent x plus delta. Now this is towards the left. As per the sign convention, we will take minus. So K equivalent means what? K1 plus K2 into x plus delta, right? Is equal to m as it is. Now acceleration. Acceleration is in the direction of the upward force, that is in the right direction. So I will take it as a positive. So mx double dot. Is it okay? Do you understand this? How I write this equation? This equation is very, very important. Now just solve the bracket. Now already we have studied. Yes, already we know that what is mg sin theta? Mg sin theta is equal to K1 plus K2, K1 plus K2 into del, right? Mg sin theta is equal to K1 plus K2 into del. This is from the static equilibrium condition. So put here, we are getting K1 plus K2 into del, right? Minus, solve the bracket, K1 plus K2 into x, okay? Minus K1 plus K2 into del is equal to m into x double dot. Is it okay? Have you understand? So from this you can see that mg sin theta k1 plus k2 k and this term will get cancelled. Okay. Now these two terms will get cancelled, and finally what we are getting? Finally we are getting mx double dot as it is plus what we are getting, k1 plus k2 into x, right, is equal to 0. Okay, if I go here, so you can see it is minus k1 plus k2 into x, and this is mx double dot. So you can take to this left hand side, or you can take it to the right hand side. So the negative sign will become positive, right? So mx double dot plus k1 plus k2 into x is equal to 0. Okay, is it clear? So from this, what you will get, x double dot plus k1 plus k2 divided by m into x is equal to 0. Okay, is it clear? Tell me, have you understand this or not? X double dot plus k1 plus k2 upon m is equal to, how I have generated this
Yes, sir.
equation. Okay, now what is the next step? After generating the final equation, we compare it with some equation. So with which equation we compare this particular generated equation? Anybody? Hello?
Second equation.
Compare with the simple harmonic equation, equation of simple harmonic motion. What is that equation? What is that equation? X double dot plus omega n square into x is equal to 0. So from this you are getting omega n is equal to square root of k1 plus k2 upon m, radian per second. Okay? Everybody please switch off your mic. So this is how I am getting the final equation. So from this, finally I am getting Fn is equal to 1 upon 2 pi square root of k1 plus k2 upon m radian per second. This is the final equation. Okay. Now this is actually the final answer, and if you are approaching to this answer, you are getting a full marks. But basically you can modify this equation also. I will just show you, it is not necessary, but I will just show you how to modify the equation. Okay. So how will you modify this equation? So let me clear out this. Okay. Now we know that what is the final equation? Fn is equal to 1 upon 2 pi square root of k1 plus k2 upon what I've got, m hertz. Okay. Now in the static equilibrium condition, I have got an equation mg sin theta is equal to k1 plus k2 into del. Right. This is my equation number 1. From this equation I am getting k1 plus k2 divided by m is equal to what I will get, g sin theta upon del. Okay. So this is one relation which I am getting. See, theoretically this is not necessary, but practically sometimes if you are not knowing k1 and k2, and if you are not knowing m, but you are knowing del and you are knowing g is obviously a constant, and if you are knowing a theta, so sometimes you can calculate natural frequency from this expression also. So what will be the natural frequency? Fn is equal to 1 upon 2 pi, and what is k1 plus k2 upon n? G into sin theta upon del, hertz. Okay, natural frequency is always expressed in hertz, right? I hope it is clear to all of you. Is it clear? Message me
Hello.
yes. Yes. Yes.
सर k1 plus k2 ची डायरेक्शन जरा सांगा एकदा.
K1 plus K2. Okay. Sure. K1 plus K2. Now, basically, you try to understand that. See, I will explain here in this direction. See. Now, basically, let us say this is m, right? Mass m. Now, what is the direction of motion? The direction of motion is always in the direction of the upward force. Is it clear? So, let us say I am applying a force in this direction. Now, basically, we are dealing with the model free undamped vibratory system where we are not applying a continuous force. We are just giving a small initial displacement. That is why we are not showing the notation F. Be clear. So I am not showing a notation F. I am just giving a small angular displacement. Sorry, small linear displacement X. Now, linear displacement X is in this direction. Okay. Now the spring force is always in the direction of, is always opposite to the upward force or opposite to the motion. So motion is x. So this k1 plus k2 will be in this direction. K1 plus k2 into x. Now basically, first of all, we have a del. in a static condition. So that will become del plus x, right? And k1 plus k2 is opposite to this x. Is it clear? And according to the Newton method, we are taking all the forces to the right positive, all the forces to the left negative. Is it clear?
Yes, yes.
Is your doubt clear? So that is why here I have taken minus k1 plus k2. Here I have taken minus k1 plus k2 into x plus del y, because this is opposite to this motion x. And mg sin theta and mg cos theta, they are as usual, as we saw in the mechanics. Now please tell me, is your doubt clear or not?
Yes, sir.
Okay. So chalo. So this is how to solve the problems of a string mass system loaded on the inclined plane. So already we have studied how to solve the spring mass system which are vertically or horizontally suspended, or pulley if they are connected to the pulleys. But basically when they are on the inclined plane, we have to also take care of the static equilibrium condition. Basically, it is not necessary. Theoretically, it gets cancelled, as I said in the earlier theoretical part. But practically, sometimes if I don't know K1, K2, and M, how will you find out the natural frequency? So, if you know G, it is it is a standard 9.81 meter square. If you know del and if you know theta, so that is why the static equilibrium condition is very very important also. Sometimes to find out the natural frequency. Okay, so now we'll be solving a problem number 8. Now again, please watch carefully how I draw the FAD. Determine the natural frequency of a falling system. Now basically this M, mass M, is nothing but a slender bar. Okay, this is nothing but a slender bar. Now up till now we have solved a different types of problems. So this is again a different type of problem. That is a slender bar problem. Now here you can see that the slender bar is vertically suspended with the help of a two spring having a stiffness K and K. Okay. Now this slender bar is pivoted at where? It is pivoted at this point O. Pivoted means what? It is fixed at this point O. Means what? It will rotate by angle theta about this point O. Okay. And basically where is the CG acted? CG will be acting at this position. So we know that L plus 3 plus 12 plus 3 is equal to L. So CG will be acting at L by 2. So this is nothing but a CG which is acting at L by 2. So this we have to analyze. It is not given. Okay. So basically how to start such type of problem? Now here basically in this problem we are not giving a linear displacement, we are giving an angular displacement. So let me uh, assume that this, or let us say that theta with a small angular displacement given to the mass L. Okay, so in this direction, see, in which direction? In a clockwise direction, I am giving a small angular displacement theta to the mass L. Is it clear? Now, first of all, tell me, when I am giving a small angular displacement theta, how will this particular slender bar will rotate? It will rotate about the CG, or it will rotate about this point O? Anybody?
About the point.
Rotate about the
About
point
the
O.
point O.
About the point O. So what will happen to this CG? Let us say this is G. What will happen to this G? Now basically it will get displaced. Yes, very nice. This G will get displaced to G dash. If you understand this, it is very easy. So now what is the task? You have to find out the distance between the O and G. Because we are always interested in the distance between the O to the G, or distance between the O to the K, or distance between the O to the K. Why? That I will explain. Okay, so first of all, let me draw a free body diagram. So for that, I will take a, first of all, let us say this is a bar. Okay, see how I am drawing this. Let us say this bar is called as a point number 1. Let me call this as a point number 1. Let me call this as a point number 2. Okay, now let me call this as a point O, and let me call this as a point G. Okay, now as I said that this bar will get displaced in which direction? It is displacing in the downward direction, because I am giving a, you can also give upward also, that's your choice. Okay, so let me give the displacement. Okay. So you can see the displacement at this point O. Okay, is it correct? So this is the displacement. Okay, so this point 1 will go. Okay, this, let us say this point is 1 dash. Wait, let me take an eraser. Okay. Okay, let me say this point as a 1 dash. So let me call this as a point 2. Okay, and let me call this as a point 2 dash. Okay, so first of all, have you understand how I got this point 1, 2, 1 dash and 2 dash? Okay, when I'm giving a small angular displacement theta. This is a very basic problem which you have to understand, and slightly a different problem. Okay, this is the point O. Now you know that this is theta, this is theta. Now first of all, let us mark the distance. Okay, let us mark the distance. Now it is very important. First of all, you have to mark the distance. Otherwise, you will not able to solve the problem. Okay. So what is this distance? Distance between the O and point 1, it is L by 3. Distance between the point O and point 1 dash, it is 2L by 3. And what is the distance between this CG? Anybody? What is the distance between this point 1 point and the CG? It will be what?
L
Always
by 2.
L by 2. It will be all by 2. Okay. See how I am drawing the free body diagram. It is very, very important. Now, as I earlier said that I will change the color frame. This G point, this is the G point. So what will be this point? This point will be G dash. Okay. Let me erase out this. Okay. Let me take another pen. Okay. So this is nothing but the G point, G dash. Okay. Now, guys, you have to understand that first of all you have to find out the distance. So let us say that the distance between the point 1 and 2 is x1. So what is x1? X1 is the displacement of this k. Let us say that the distance between the 1 dash and 2 dash is the x2. It is nothing but the displacement of the spring k. And let us say that g to g dash is the distance x, and this x is nothing but the translational motion of a slender bar. Means what? Translational motion is what? The CG is translating from g to g dash. So I have got the three parameters x1, x and x2. So now you can see that the system becomes a multi-degree of freedom system, but I am interested in a single degree of freedom system. So I have to convert this all x, x and x2 in a single theta, or maybe single x, or maybe x1. So as I said that we will convert it into the theta. Only a constant parameter, or you can say a one parameter. Now first of all, tell me, have you understand this free body diagram which I have drawn? Anybody is having a doubt in this free body diagram of a simple slender bar suspended vertically and given a small angular displacement theta. Okay. So whatever may be the problem, okay. Sometimes you are let us say if this is fixed. Sometimes if CG is fixed, means what? If the CG was fixed, what would have happened? Anybody? If CG was fixed, what would have happened in this case? If CG was fixed, it would have become a very easy condition. But what
X1 will be X2.
no, X1 will be no, we don't know whether it is X1 or X2. That is not the case. But there would not be X. There would not be X. Why? Because if CG was fixed, the CG will not get displaced. Na? Means what I mean to say is that in this particular problem, you have both rotational and the translational motion. What is rotational? This bar is rotating about the point O by theta. What is translational? CG is displaced from G to G dash, and the translational linear displacement is X. Okay, but if the CG was fixed, there would not be a translational motion. There would be only a rotational motion. Is it clear? So now we will solve the problem. Okay, so let us start. In this case, first of all, we will solve by the equivalent method. So kinetic energy of the system is equal to kinetic energy of bar translational plus kinetic energy of bar rotational. Why translational and why rotational? Because CG is not fixed. You can see in this figure, CG is not fixed and it is getting displaced by X. Okay, clear? Now, first of all, you have to find out the distance X. Now, anybody, how will you find out the distance X? What is X? What is X? To find out the X, I will draw this triangle. Let me see, this is the triangle. Okay, what is this? This is O. Okay, what is this? This is G. What is this? This is G dash. What is this X? So to find out the X, first of all, you have to find out this distance. No? So anybody, can you tell me what is this distance? What is
L
this?
by 2 minus L by 3.
Yes, yeah, very nice. L by 2, because the total distance between the point 1 and G is L by 2 minus 1 and O. Means what? It is nothing but 1 to X minus 1 to O. This is the distance. Okay. So it is very, very correct. So the answer is X is equal to L by 2 minus L by 3, that is equal to L by 6 theta. L by 6 into theta, because I have considered this figure, na? I have considered this triangle. So this is X, this is L by 6. Let us say this is theta, this is point O. So X is equal to basically what? L by 6 into sine theta. But we know that sine theta is equal to theta because displacement is very, very small. x becomes L by 6 into theta. This is what you have to understand. Okay. So x is equal to L by, so what is kinetic energy of bar translation? 1 of mx dot square. Very, very important. The displacement of the CG is x. So here you will not write mx dot 1 or mx dot 2. It is 1 of mx dot square. The rotational is 1 of I theta dot square. Okay. So x dot is equal to what? L into 6 theta dot. So put everything here. So 1 of m into x dot square. X dot square means what? L by 6 into theta dot square. So ml, so that becomes m into L square upon 6 square 36 theta dot square. And now guys, very, very important, I, that is a mass movement of inertia of a slender bar, is ml square by 12. This you have to remember. So I am putting this I is equal to ml square by 12 and theta square as it is. Theta dot square as it is. Is it clear? Is it clear? Now what is the next step in equivalence method? You have to remove constant 1 up and you have to constant remain theta square. Okay. Is it clear? Am I audible? So you have to remove half and theta square constant. Okay. So 1 up ml square 36 theta dot square plus 1 up ml square 12 theta dot, it is 3 theta dot square. So what will happen? Kinetic energy is equal to 1 up ml square 36 plus ml square 12 theta dot bracket square. So this bracket term is called as what? This bracket term is called as what? I equivalent. This bracket term is called as the I equivalent because it is in terms of theta, na? Guys, am I correct or not? Or you can also call it as a M equivalent also. Even if you are writing it as a M equivalent, doesn't matter. I and M are one and the same. Only the system changes, linear or torsional. Okay? Is it clear? So tell me finally what you are getting I equivalent. So kinetic energy is equal to 1 of ml square plus 36 plus 1 of ml square by 12. You are getting ml square by 9. So M equivalent, or you can write it as a I equivalent as ml square by 9. So you are getting I equivalent or M equivalent as ml square by 9. Because you know that natural frequency omega n is equal to square root of k equivalent upon M equivalent. So basically I will suggest you that whenever you are solving a problem on the problem on this slender bar, don't go for the differentiation method. You can, but basically it will create a complex situations. Okay, guys, have you understand this? How I've got this? Now potential energy. Anybody? Now to find out the potential energy, first of all I have to find x1. For x1, I will consider this as a triangle O, 1, 2. This is x1. So first of all, you have to find out this distance 1O. What is this distance 1O? What is this distance 1O? L by 3. So what is x1? What is x1? L by 3 into theta, right? Now guys, you have to again find out this x2. To find out this x2, see, always you have to consider from this point O. Remember that. Point O, this is 1 dash, this is 2 dash, this is x2, and what is distance O1 dash? 2L by 3. And this is theta. So tell me what is x2? Anybody? What is x2? What is x2? 2L by 3 into theta. So this is x1 and this is L2. Now please message me, have you understand how to find out this distances x1, x2, how to find out this displacement, which triangle you have to consider. You have to either consider this triangle, you have to consider this triangle or this right angle triangle. Okay. So basically this you have understand. So now tell me what is the potential energy of the system. So let's find out the potential energy of the system. So potential energy of the system is 1 half k into x1 square plus 1 half k into x2 square. Why? Because we have two springs. Okay. Now we know that that is equal to 1 half k into what is, okay, 1 half k into what is x1? What is x1? L by 3 into theta bracket square, right? Plus what is again k into I we half common काढले हा समजून घ्या. Plus what is x2? 2L by 3 into theta square bracket complete. Okay. So 1 half what we will get kl square upon 9 plus 4kl square upon 9, and let me remove the common theta square. Okay. Now you are getting finally 1 half kl square 9 plus 4kl square 9 means what? phi k square upon 9 into theta square. Now anybody tell me what is this term phi k into square? This is equal to 1 of k equivalent into theta square. Or you can call it as a kt equivalent. You can call it as a kt equivalent. So what is kt equivalent here? What is kt equivalent? Anybody? What is kt equivalent? So I'm getting kt equivalent is equal to pi k L square upon 9. And what is I equivalent? I have already find out. Anybody? What is I equivalent? I have already find out. ML square upon 9. ML square upon 9. Okay. So finally, guys, Fn is equal to 1 upon 2 pi square root of, you are getting kt equivalent upon I equivalent. So you are getting final answer 1 upon 2m is equal to, you are getting pi k upon m. Now please tell me, have you understand this problem, how to solve? Anybody? Is there any doubt in this? Have you understand how to solve the problems on the slender bar by using this formula? Hello? Yes, Rajendra and all. Have you understand? Is there any
Yes,
doubt?
sir.
काय डाऊट असेल तर मला विचार आत्ताच. कुठलाही प्रॉब्लेम, कुठल्याही पॉईंटचा जर तुम्हाला डाऊट असेल, यू कॅन आस्क मी. जर डाऊट नसेल तर मी नेक्स्ट टाइप ऑफ प्रॉब्लेमवर जाणार आहे. सो आय will now solve the problems on the schema system, pulley system, inclined problem. Then I have taken the slender bar problem. Now I will take a problem of a simple pendulum. Shall I go forward to the next problem? Hello? Shall I go to the next problem? Okay. Now basically this is a very simple problem which will not appear in your exam. But this simple pendulum may be connected to the spring or may be connected to the mass. But before that, you have to understand the basic how to solve this simple pendulum problem, and then we'll go on to the next problem. Okay. Okay. Now, let us say that find the natural frequency of the oscillation of a simple pendulum given that the mass is m in kg suspended from the point O and the length is h. Now, anybody can tell me what is the first step when this simple pendulum will start oscillating? When simple pendulum will start oscillating? Yes.
Initial angular displacement.
Initial angular displacement. So first of all, you have to draw the free body diagram, a basic free body diagram. So first of all, I will solve by the energy method, then I will solve by the D'Alembert's principle or Newton method. Okay. So let me solve this. This is a mass m. Okay. Mass m will move here. Okay. Let me say that this is this point. Okay. So anybody can tell me what is the distance this? Okay. What is this? Okay. Anybody? This is theta, na? This is theta. This is point O, right? This is L. This is M. Okay. This distance is h. Now anybody knows that if this is the theta, this will be also L. I will change the color pen. So this will be also L. So this will be theta. So this will be all L cos theta, and this vertical distance from this point to this point. Let me call this as a point O dash. So L sin theta. Okay. So this is what L cos theta. So tell me what is the distance h? Anybody? What is h? What is h? What is h? I have already explained you.
L minus L cos theta.
L minus cos theta, right? Okay. Have you got this? Now, this is the basic diagram which I have drawn, or the free body diagram which I have drawn from the orientation diagram. Okay. Now apply the energy method. So total energy of a system, sorry, is equal to constant. Okay. So what is total energy? Kinetic energy plus potential energy is equal to constant. Now in case of the simple pendulum, what is kinetic energy? Kinetic energy of mass m. What is mass m? What is mass m? Mass of the ball. Now tell me, it is rotational or translational? Kinetic energy of mass m is rotational or translational? Hello? Okay. Your mass m is displaced by angular displacement theta, na? Your mass m,
Rotational.
yeah. So you have to consider only a rotational distance. Here there is no, you can say, you can't say that the CG is displaced or not in this case. Okay. Because what happens, we are neglecting the mass of this. We are neglecting the mass of the string. This is a string now basically, and we are considering that string is having a very less mass as compared to this. So that is why we are neglecting the mass of the string. So means what? There is no CG of this mass. There is no CG of this mass, and that is why this G will not move to the G dash. This G will not move to the G dash. Means what? Instead of this string, I have taken let's some slender bar, and slender bar is connected to this mass end. Then we have to take translational motion also. That is G will get transmitted to the displaced to the G dash. Is it clear? But in this case, we are assuming that this is a massless because it is a very small string. So we will not have a translational motion because the CG of the string is not considered. Na? I hope it is clear to you. Yes or no? So there will be only a rotational motion theta and plus potential energy of the mass potential. Now basically I have explained you that we have two types of potential energy. One is the strain energy and one is the potential energy due to the datum position. So in this case, tell me which energy you will consider. Potential energy mgh or potential energy 1 of k into x square, and why? Hello?
MGH.
Why mgh? Mgh? Why not kx square? 1 of kx square?
String is not there, so
Because there
stiffness.
is no any elastic body. There is no any elastic body. You can't say spring, but there is no, even if there was a shaft, there is no shaft, there is no beam, there is no spring. Okay. So basically strain energy is stored inside the elastic element because strain energy is also called as the internal potential energy. Okay. So here we have a kinetic energy of mass m rotational. Plus here we will have a kinetic energy of potential energy of mass. You can potential energy of mass m. So potential energy of mass m is equal to constant. So let's start 1 of I into theta dot square plus, now what is potential energy of mass m? Potential, how to write? mgh is equal to constant. So 1 of, what is I? What is I? Cos simple pendulum. Anybody? Plus what is mg? What is h? L into 1 minus cos theta is equal to c. Okay. Now do a cross multiplication. 1 of I into theta dot square plus mgl minus mgl cos theta is equal to c. Now differentiate. Okay. Now differentiate with respect to time, with respect to time t. Okay, with respect to time t. Means what? You have to differentiate with respect to time t. Which term? What is your parameter? Theta. So you have to different, means what? You have to take d theta by dt, right? You have to take d theta by dt. Chalo. Now tell me, how will you write down the differentiation? How will you write down the differentiation? If you want, I will write here again. 1 of I into theta dot square plus mgl minus mgl cos theta is equal to 0. Okay. Chalo. Differentiate. Anybody? 1 of I 2 theta dot into theta double dot plus this mgl term will be 0 na, because there is no theta term, it is a constant, and now minus mgl as it is constant, minus mgl as it is, and cos theta, derivative of cos theta minus sin theta, so this sign will become plus, so sin theta and into derivative of theta, theta dot is equal to 0. See how I have taken a derivative. 1 of I into 2 theta dot into theta double dot 0 mgl psi mgl as it is constant, sin theta cos theta derivative minus sin theta, so minus sin will get plus into theta dot is equal to 0. Okay. Now here you know that this 2 will get cancelled, so theta dot will get cancelled, theta dot will get cancelled, so it will be I theta double dot plus mgl into theta because sin theta is equal to theta. Okay, so finally I am getting theta double dot plus mgl upon I into theta is equal to 0. Now compare it with the standard equation. Compare it with the standard equation. What is the standard equation? Theta double dot plus omega n square
For the omega.
into theta is equal to 0. So finally I am getting omega n is equal to square root of mgl upon I. Okay. Now basically for a simple pendulum which is connected to a string suspended vertically, what is I? Mass moment of inertia. Mass moment of inertia for a slender bar is ml square by 2l. Similarly, What is the mass moment of inertia for a simple pendulum? For a simple pendulum which is connected to a stream and the mass is neglected, your I is what? ml square. I is only ml square. Okay, remember this. So Fn becomes 1 upon 2 pi root of mgl divided by ml square, that is equal to 1 upon 2 pi square root of, what do you get? G upon L hertz. Okay. So now tell me, have you understand this energy method? How to solve the problems on a simple pendulum by using energy method? So same you can use and apply the D'Alembert's principle, and you will get the same answer, I guess. So within a quick, I will show you D'Alembert's principle also. Okay. Is it clear, all of you? Hello. Is it clear or not? Please message
Yes,
me
sir.
the same. Okay. Now I will solve the same problem by D'Alembert's principle, because sometimes or D'Alembert's principle and Newton method, one and the same. Sometimes they may ask you find the natural frequency of a simple pendulum by using a D'Alembert's principle or by using a Newton's method. So first of all, how to solve this problem? Okay. First of all, you have to draw the free body diagram. Okay. Free body diagram. So first of all, what is the first step? Give a small displacement theta for the angular displacement. Okay. So mass m will get displaced. So this is a displaced position, right? Now let me say this is a theta. Let me say this is L. Let me say, okay. Now in this case, as I said earlier, that whenever you are solving a problem by the Newton's or D'Alembert's principle, you have to consider the mass m into g. That is a weight which is acting downward direction. Okay. So let me say this is a displaced position. Let us say this is a mg which is acting downward, right? In energy method, there is no need of taking this mg and no need to resolve this component mg sin theta and mg cos theta. But in Newton's method, you have to resolve the component. Is it okay or not with you? Okay. So let me change the color. So what is the vertical component? mg cos theta and mg sin theta, right? So this is mg cos theta and mg sin theta. Have you understand why this is mg cos theta and mg sin theta? Because if I draw this diagram like this, okay, if this is the theta, if this is the theta, this will be theta, alternate angles. So this will be theta, right? So if this is the theta, then this is mg cos theta, and this vertical component is nothing but a mg sin theta. Okay, have you understand this? Have you understand this resolution or not?
Yes, sir.
Okay, so mg cos theta, mg sin theta. Now tell me, in which direction you have applied an angular displacement? Means what? In which direction you have given initial displacement? You have given initial displacement how? Anti-clockwise, na? So if theta is the acting in anti-clockwise direction, theta dot and theta double dot will also act. Means what? The acceleration induced inside a dynamic system or a vibratory system will be in the anti-clockwise direction, in the direction of the applied motion or the applied force. Okay. So as I said that if if the acceleration is acting in the anti-clockwise direction, the inertia force or inertia torque will always act opposite to the acceleration. Right, na? Is it okay? So what is inertia torque? How do you calculate the inertia torque? Inertia force is mx double dot. So how do you calculate the inertia torque? I into what? Anybody? I into theta double dot, na? So now I will show you how the torque will act on the system. Why I am calling it as a torque? Because it is a torsional system, not a linear system. You know that inertia force and inertia torque are one and the same. Only the system will change. Okay. So let us say this is a m. Okay. I will erase this to I will try to make it simple. Okay. So let me show how the torque will act. Oh yeah. Again, I am making a same mistake. Okay. So let's say this is a mass m. Okay. So mass m has moved here at this point. I am trying to make the system simple. Okay. So now I will change the color pen here. So what is this? This is mg, right? And what is this? mg cos theta, mg sin theta. This distance is L, this distance is theta. Okay, so now we know that theta double dot acceleration is acting anti-clockwise, so I theta double dot will act clockwise. Okay, so what is this I theta double dot? Inertia torque. Okay, theta double dot and theta are acting anti-clockwise, so I theta double dot is nothing but the inertia torque will act opposite to the displacement. Okay, and what is the external torque? Anybody? So now we have got the inertia torque. What is the external torque in this case? Which is the external torque which is trying to bring the system to the static condition or the equilibrium position? What is the inertia torque? Yes, anybody? Okay, what is the external torque? What is the external torque which is acting opposite to this I theta double dot? Sorry, theta double dot. Mg sin theta into
Theta L.
you can see now this
L.
is the point O. Yes, mg sin theta. This is nothing but a force, and the line of action of the force is about this point O. So multiply by this distance L. So external torque is nothing but the mg L sin theta. So this is very important. You have to understand. Okay. Now I will move on to the statement. Statement is very easy. Summation of inertia torque plus summation of inertia torque bracket external torque. Okay, external torque is equal to 0. What is this? This is a D'Alembert's principle statement. So what is now in D'Alembert's principle? No need to take care of the sign. So I into theta double dot plus what is external torque? mgl into sine theta is equal to 0. Okay, so this will become I theta double dot plus mgl into theta is equal to 0. What is mgl? What is sine theta? Theta. Okay, so now I will get theta double dot plus mgl upon I into theta double dot is equal to 0. Right, now compare this with the standard equation. You are getting Fn is equal to 1 upon 2 pi square root of mgl upon I. And what is I? Basically, what is I? Anybody? Just now I have told ml square. You are getting g upon L into hertz. So finally, you are reaching to the answer at an earliest. So it's your choice which method you have to apply, unless and until it is asked in the particular university examination. So tell me, have you understand both the methods, energy method as well as the D'Alembert's principle? Anybody has any doubt, you can ask me the question. Okay. So in energy method, you have to take kinetic energy of a mass m translational and kinetic potential energy of a mass m mgh. In Newton's method or D'Alembert's principle, you have to consider the inertia torque I theta double dot, which is acting opposite to the theta double dot. And theta double dot is acting in the direction of the theta, means what? In the direction in which you are giving the displacement. Mg sin theta into L is nothing but the external torque, which is also acting clockwise. So guys, try to understand that both the torques are called as a restoring torque. Restoring torque means what? They will try to bring your system to the equilibrium position. They will try to bring your system to the static condition or steady state condition. The transient system will come to the steady state condition unless when and then only when your particular restoring torque will come into the action. So is it clear? Have you understand this?